In this video, we will learn how to calculate the inverse of 3D matrix. Steps to calculate the inverse of 3D matrix. We have one step, two steps. First step is we calculate the determinant of A. If the determinant of A is not equal to 0, A is invertible and we calculate the inverse. Otherwise, if the determinant of A is equal to 0, A is not invertible and we stop there. Second step is, if A is invertible, we choose any method to find the inverse, such as cofactor expansion rule, and we already explained it in the previous videos. Second step is Gauss-Jordan elimination. In this video, we'll talk about Gauss-Jordan elimination. Now, first step is we calculate the determinant of A, this matrix A, okay? So we take our matrix, this is the original matrix, we take the original matrix 3 times, 1 time, 2 times, 3 times. Then we choose first number in the first column and first row, second number in second column, first row, third number, third column, first row. Then we remove everything, we ignore all numbers below 1 here, and vertically and horizontally we do the same with here also, and we do the same here. Then we had 1 here, right? Or you can look at this one also, it is this, they are the same basically. So 1 1 minus 1 minus 1 0 0, okay? So we take our 1 here and we put it here, then we multiply it by this new matrix, 1 minus 1 0 1 1 minus 1 0 1 minus, this minus is coming from our rule. We have a rule to calculate the determinant, so always we take plus minus plus, okay? So minus, and we have here we have minus 1, right? So minus 1 multiplied by 0 minus 1 0 1, so 0 minus 1 0 1 plus, we had 0 here, right? So 0 multiplied by 0 1 0 0 0 1 0 0. Then we take our 1, we don't touch it, and we multiply 1 multiplied by 1 1 multiplied by 1 minus 1 multiplied by 0 minus 1 multiplied by 0. We take our minus again, then, and minus 1 also we don't touch it, multiplied by 0 multiplied by 1 0 multiplied by 1 minus 1 multiplied by 0 minus 1 multiplied by 0 plus 0, we don't touch it, 0 multiplied by 0 0 multiplied by 0 minus 1 multiplied by 0 1 multiplied by 0. So since here we have product with 0, it is 0. Here also you have product with 0, it is 0. Finally here we have here 0, but we have 1 multiplied by 1 is 1, and multiplied by 1 again it is 1. So finally you get 1. Since the determinant of A is equal to 1, hence A is invertible, and we calculate the inverse. Now to find the inverse of matrix A using Gauss-Jordan elimination, we transform the augmented matrix through a series of row operations. Keep this in mind, series of row operations. We work with rows, okay? Where the left side becomes the identity, okay? So this is the identity matrix, okay? Matrix, and the right side becomes the inverse of A, okay? This is the identity matrix, and this is the original matrix. We'll see the example to understand it better. Now let's see this example. We have our original matrix A, and here we have the identity matrix. And what we need to do is, we have to do some operations on this matrix to get finally the identity matrix here, and what we what we will be done on this matrix, any operation is done here, it will be done here also, and finally we will get the inverse of A here. Okay, so what we need to do now is we need to change this -1 to 0 and this -1 to 0 to get the identity here. Okay, and as I said, any operation is done here, it will be done here also. Let's do it. So first we take row 2 plus row 3. So row 2, this is row 2 plus row 3. Why we need to do that? Just we need to change this -1 here to 0. So -1 plus 1, we get 0, right? So let's do it. We will do all of them. Okay, we'll do all this row plus this row, third row. So row 2 is equal to 0 plus 0, 0 plus 0 is equal to 0. That's why we get 0 here. Okay, and then 1 plus 0 is equal to 1. Okay, then -1 plus 1 is equal to 0. That's why we get 0 here. Then 0 plus 0 is 0. Okay, then 1 plus 0 is equal to 1, and finally 0 plus 1, that's why we get 1 here. Okay, now second step is we have to change this -1 to 0. Let's do it. So we just erase. Okay, let's do it. So row 1 plus row 2, row 1 plus row 2. So we do it like that. Row 1 is equal to 1 plus 0. 1 plus 0 is equal to 1. That's why we have 1 here. And we do the same steps. So -1 plus 1 is equal to 0. That's why you get 0 here. And 0 plus 0 is 0. Nothing changed. Here, 1 plus 0 is 1. Okay? Now 0 plus 1, so you get 1 here. Okay? You see? And again, 0 plus 1, you see you get 1 here. Okay? So finally we get our inverse of A. It is this one here. Okay, so you get 1 1 1 0 1 1 0 0 1. It is the same one here we got. Okay, so we got the identity here and we stop. Once we get the identity here, we stop, meaning we got the inverse on the right side, and here it is the inverse. Okay, thank you for watching.